Hey everyone, welcome to OpenSearchCon 2023. I'm super excited to be here with all of you today. It's great to see so many of you returning from last year, and I'd like to extend a special welcome to all of you joining for the first time. We are so glad to have you as part of our community. For those of you who don't know me, my name is Eli Fisher, and I'm the product leader at Amazon working on the OpenSearch project. We've got a ton of exciting news today, so let's just dive right in. It's been an amazing year for our community. I really feel like OpenSearch grew up this past year, don't you? In every area and in every way, growth has been the fundamental driving force behind what we have achieved together. I've worked on open source projects before, but the OpenSearch project is the first that I've worked on that has experienced this type of explosive growth. Let's take a look at a few exciting growth numbers. OpenSearch has been downloaded more than 320 million times since it was launched, with over 230 million downloads this last year alone. OpenSearch now has 70 partners, with more joining every week. And the OpenSearch Project Slack, which launched this April, is already grown to over 1,300 members. When it comes to software contributions and participation, we've also seen significant growth. The OpenSearch project encompasses more than 100 repos with over 1,000 individuals contributing. Across the project, there are more than 200 maintainers spanning 19 organizations. There have been over 38,000 pull requests merged and over 16,000 issues closed. So, why are we seeing this growth? What makes OpenSearch different? When OpenSearch was released, July 2021, there weren't many options for a truly open source toolkit that combined the rich set of search and analytics capabilities that OpenSearch offers. By putting OpenSearch under the Apache 2.0 license, people were able to rapidly build, experiment with, extend, and sell their own applications on top of OpenSearch. There is also a strongly held belief that a small but mighty cohort of people who cared about open source like you would join us in making this project successful. This belief has since become a reality, and it's been pretty amazing to see. What strikes me the most is that the success of this project can't be traced back to the founders directly. Success was dictated by all of you, the community. Sure, folks like myself, we connect the dots, we point people in the right direction. But you are writing the code. You are defining the feature requirements. You are working together to build the next set of capabilities for OpenSearch. You are making OpenSearch happen. And I could not be more thankful for all of your contributions and to be here with you today. Our community growth is one of the many reasons people and organizations around the world are using OpenSearch to build solutions for a vast array of search and analytics use cases. Seeing companies offer OpenSearch as part of their core business is extremely rewarding because it's proof that this is a working model. It's proof that the community's ideas are based in reality and opportunity. And it's proof that OpenSearch solves real search and analytics problems. I'm thrilled to invite Jim Battenberg, Director of Product Management at Oracle, to our stage. His team built a managed OpenSearch offering for Oracle Cloud, and they did it quickly. Jim is here to share more about what they've been building with OpenSearch, his take on open source contributions, and their experience building as a member of this community. Please, everyone, join me in giving a warm welcome to Jim.
Hey, everyone, can you hear me? Okay, awesome, thanks. As Eli said, I'm Jim Battenberg. I lead product management for a handful of open source managed projects, including OpenSearch, Redis, and Postgres, and Cassandra. And I'm here today to talk to you a little bit about our experience, as Eli said, with OpenSearch. But before that, I want to talk to you a little bit about Oracle's role in open source in general. So why open source? I think we all know, anytime you get a collective expertise, especially a diverse collective expertise together focused on code, you end up with rapid innovation, you end up with creative evolution, and that translates into innovation. With a large community looking at code all the time, vulnerabilities are found and fixed quickly. It's well known that open source software is highly secure. It's also flexible / portable. You can take open source software from one project to another, from one cloud vendor to another, from one company, from one job to another. I debated putting a fourth icon on here with a $, kind of like the 8-bit video for free and cost savings. And while it's true, open source software is free and a lot less than commercialized software that's, expensive, elastic, excuse me. It's not always free, right? Some of our customers have told us that, yes, open source software is cost effective, but it's not as easy as it looks. And I need support. And managing and securing open source based solutions is hard. So what's free can cost dearly. Thus, the need for managed open source services, which you're starting to see grow around the industry. Open source is going nowhere. I've been a part of open source since I can remember, probably free Unix days for those of you in the crowd that can remember that. There's over 400 million contributions in GitHub last year alone. 90% of the Fortune 100 are using open source software. And Oracle's a big contributor to that. I won't run you through everything on this slide, just a few items. To show our interest and commitment to open source. We still actually contribute to the Open JDK from a Java perspective, even though we have an Oracle JDK that we continue to evolve. MySQL came to us through the acquisition of Sun back in 2010, and we have continued to offer a free and a commercialized version since that time. We've also improved on top of MySQL with a product called HeatWave, very interesting machine learning analytics across data lakes and data warehouses. Footnote, not free, but very powerful, very cost effective. I'll draw your attention to the bottom right where you see a little box called Tribuo, which is a very interesting machine learning, Java-based machine learning software product that comes out of one of our research groups that we call Oracle Labs. And they're finally getting their day in the sun as the industry fervor around ML and AI continues to grow. They do regression and multi-class classification and anomaly detection and a bunch of interesting things that I think will coalesce with OpenSearch over time. And you're probably familiar with the Oracle Penguin in the upper right of the slide. Oracle Linux has been around for a while. It's a very powerful product and a lesser known service, if you will, or product that can sit on top of it. It's called OS Management Service. Also free, does a lot more than updating and patching. You can actually look for specific CVEs. You can scan to see what's running on top. There's a whole bunch of really nice functionality that's also free. So very nice. I'll move on from here. The Linux kernel, as you know, is built by many, right? Oracle is the #1 contributor to the Linux kernel. We continue to build and contribute to lots of projects. From a Kafka and Hadoop perspective, for example, we continue to contribute bug fixes, performance improvements, compatibility with, of course, Oracle databases and Oracle Cloud Infrastructure. And we maintain memberships with the major foundations, if you will, that are cloud native and focused on open source solutions. So that is translated into a suite of managed open source services that Oracle provides. I'll talk about just a couple here. We've got a serverless Spark offering called Dataflow. We've got Hadoop offerings, big data service. We now have Redis in-memory DB/cache in limited availability. We also have Postgres in limited availability, and of course, OpenSearch, which is the meat and potatoes or tempeh and broccoli for what we're all here to talk about. So let's talk about that for a minute. OpenSearch, we launched version 1.2.4 back in May of 2020. And it's been quite a ride. We've grown very quickly. As you can see here, we are well over 100,000 cores, more than 1.3 petabytes of RAM, over 100 petabytes of block, and we're growing. Interestingly, at least to me, Our use cases are inverted from what I was expecting. We're actually seeing more log analytics, and you can put a little bit of observability under that, and less application and enterprise search than I had expected initially. But with the advent of 2.9, neural search, and then bringing in, KNN and ML Commons and what have you, and the capabilities that semantic search offers, I expect this to change over time. But getting here wasn't all roses and rainbows, or whatever that phrase is. Let me share with you a couple of war stories. We'll start with Oracle NetSuite. So NetSuite is one of the leading ERP vendors. If you pull it out of Oracle, it's one of the largest SaaS companies. It's somewhere close to $1 billion in revenue. It serves 40,000 customers and offers ERP software to small and mid businesses, about 40,000 of them. Their challenge was to migrate off of Elasticsearch and onto our managed service product. And of course, super compressed time frame, more compressed than we would like, but it's always like that, right? To give you a sense of its scale and its scope, we'll fast forward. It's about 60,000 cores, 1 million gigs of RAM. I've never been able to say that before. 1 million gigs of RAM. It's pretty cool, right? That's a lot if you think about it. And nearly 40 petabytes of block storage. We were also running 3 750 node clusters and about a dozen 100 node clusters. When you scale OpenSearch to this extent, you have to rethink your constructs and your primitives altogether. We had latency issues due to shard problems. We had JVM tuning issues due to heap management and garbage collection problems. There were challenges with patching. There were a lot of challenges with implementing this scale of OpenSearch. Now, if you come back after the break, Sam, who's in our audience here somewhere, will be talking about the experiences here, and we're also going to be turning a lot of these learnings back in and over to the community from an architectural perspective, from a code perspective, and you can learn a lot more about that in the session right after this one. So Oracle RQS stands for Resource Query Service. If you have ever typed in anything in the Oracle Cloud Infrastructure console to look for something in the search bar, if you've ever gone to docs.oracle.com to look for any product documentation across Oracle, you've used RQS. So this is a service that's been collecting telemetry on any OCI resource ever deployed. It ingests, so it's got a lot of data, right? It ingests about 2 billion events weekly and growing continually. It translates into something not quite as big as NetSuite, but it's still pretty big. It's about 5,000 cores and about 2,000 gigs of RAM, petabyte of storage. And guess what? At scale, again, we had shard balancing issues. We also had some batch indexing problems. Well, we figured out that they weren't using the batch index API. So once we got them on that, we reduced latency 90%, and everything worked out really well. So by the way, both of these groups have moved completely off of Elasticsearch. Yay. And we've saved a lot of money in license fees. I don't know if I'm allowed to say how much, but a lot. And they're saving tens to hundreds of hours of person months operating, no longer operating Elastic, and then letting the managed OpenSearch service work for them. Next is Samsung. Samsung's an interesting customer, and they had some synonym issues, let's just say. Actually, a gigantic, huge synonym file that they had implemented themselves, which was just draining all their memory, right? So their queries were just breaking. We worked with them on that. We got the language packs out. We worked with them on synonyms. We worked with them on homonyms, and ultimately solved their problems, and they're a happy camper now. The last company to talk to you about is Prophecy International, which is a contact center software out of Australia. Different problem with these folks. They don't want to move, right? They're on 124. They are happy on 124. And I, have conversations with them and tell them, well, you're going to lose this functionality. And by the way, Lucine's gotten faster and this, that, and the other. They're like, we're good. We're just going to stay on 124 for a while. So, once we agreed to extend our support for 124 and the ability to create new clusters with 124, they grew their footprint and they're happy. And I think they'll eventually move to 3 when we get there. But it's always an interesting conversation when you find the customers that are just happy with what they have, because you're always balancing supporting older versions and supporting new versions and building new versions and all of that. It's a challenge, right? Okay, so you heard from Eli. every year, let me back up. Every year, the Cloud Native Computing Foundation offers a cloud native survey. Kind of like, if you remember RightScale when they used to do the state of the cloud surveys, there are a few surveys that are actually based on reality. You know that the people answering the surveys are actually working on this daily. They ask, as they do every year, what is your major concern for an open source project, for those managing open source projects? And that was lack of community support. Well, I don't have to go over the right side of the slide here. Eli covered all of this earlier, but this community is growing, and it's growing quickly. So we're doing what we can to contribute back as well. Not only are we working altruistically with Amazon on things like cloud agnostic migration, but we're also down deep in the code, right? We're looking at the dashboards upgrade project, and we're actually in there removing Angular and replacing with React. We have a handful of other PRs that are also currently in the queue, if you will. And we are really excited to be part of the community, to ride this OpenSearch wave with everyone. And that's my time. Thank you.
Thanks, Jim. At the core of any software community is a tool that solves real problems. And for OpenSearch, these problems center around observability, security analytics, and search. Take observability as an example. People use OpenSearch to ingest and analyze log data for operational insights. Since OpenSearchCon last year, we've introduced features like log patterns that help you group your logs into a smaller number of patterns to quickly identify outliers. Since people also want to analyze traces and metrics alongside their logs, OpenSearch has added support for OTel schema, Jaeger traces, and query federation to Prometheus for metrics analytics. This year also saw the culmination of an effort I'm truly excited about. OpenSearch integrations now enables you to quickly visualize insights across a range of data sources like CloudTrail, MySQL, NGINX, and more, all with pre-built dashboards tailored to that specific data source. What's even more exciting is that more data sources are being added with every release. Many people also use OpenSearch to store and search and analyze security logs and events. To make it easier to analyze security data, we launched OpenSearch Security Analytics last year. With Security Analytics, all it takes is a few clicks to begin running over 2,000 security rules across more than 25 log sources, including AWS logs, Windows logs, VPC flow logs, Zeek logs, and more. Once your rules are set up, you can also configure security analytics to automatically notify your security teams using popular tools like ServiceNow, PagerDuty, Slack, or you can use the built-in OpenSearch alerting feature. To make the analysis process even easier and further reduce incident response time, we launched the OpenSearch Correlation Engine, which analyzes relationships between security findings across your logs. Now let's talk about search for a minute. Search has been at the core of what we've been doing since the beginning, so naturally, there's a lot to talk about here. OpenSearch has always had a range of built-in search capabilities, things like inverted indexes, vector search with KNN, and many other search features. This year, the project has continued to add innovations in this space. Innovations like hybrid search scoring and search pipelines, which enable you to define multi-step search workflows for things like result re-ranking. The search space continues to evolve quickly, and I'm excited to welcome Grant Ingersoll to the stage to dive deeper into the area of search. Grant has been active in the search industry for multiple decades. Grant co-founded LucidWorks and is an avid contributor and maintainer in open source search projects like Lucene, OpenSearch, and Solar. Grant is here today to talk about one of the key questions we all have in this space. How do we better connect users to information in order to help them make data-driven decisions? So everyone, let's give a warm welcome to Grant.
Thank you, Eli. Hello and welcome, everybody. Is everybody on at least 2 cups of coffee now? I'm on my third. Anybody more than 3? No? All right. Well, maybe afterwards. Thank you so much for having me. In the next 10 minutes, I want to challenge us to think about search in ways that hopefully will take you out of some of the day-to-day grind that is putting search into production. All the bits and bytes and sparse versus dense and neural and embeddings, the algorithms, the data structures, all that stuff's a lot of fun. And it's something, of course, we have to pay attention to as engineers. And I trust over the course of today and tomorrow, and hopefully you got some of this yesterday, people way more qualified than me are going to help you increase your learnings on how to do these things in OpenSearch. But I want to ask you one very simple question. What problem are you trying to solve? Now, you might be thinking, Grant, come on, really? It's a search conference. We're solving search. But the thing is, you actually aren't working on a problem called search. Search is just one solution to the actual problem you are working on. And the reality is, for most of us working in search, we're only working on a very small sliver of the actual problem that you are trying to solve. So what is this grand problem? Well, those who study this stuff would say that we are trying to solve a user's need for information. Presumably they can take some sort of action off of like, hey, where should I get dinner tonight? Or how do I make $1 bajillion selling cloud services or whatever it is that you do? But the interesting thing, as the text says here, is many of us are not actually clear why we want that piece of information. Think about that for a moment. Think about all of your searches, all of your seeking of information. Can you actually articulate exactly what you want in all cases, or even most of the cases? Can you articulate why you think you need that bit of information? Why do you need to know exactly what are those configuration things that go into that particular solution you have in mind? Have you ever thought about how these needs evolve over time? How they connect to other things you know or other people know? What about when you're working on a really hard problem that takes weeks or months or even years for you to solve? Who and what helped you make those connections? I want to put a pin on that for a minute. They're all really fascinating questions, at least for me. They're mostly unsolvable and a source of endless both fascination and frustration for people who geek out on this stuff like me, and I'm assuming all of you because you're here. In a seminal article from 1945, Vannevar Bush and The Atlantic published As We May Think, which is mostly associated with this idea of a memex, to make knowledge more accessible for scientists in the day. Of course, a lot of this was kind of the thinking of the time. There was things like microfilm and mechanical systems that allowed you to dial up what you needed. But at its heart, Vannevar was describing search as this means for solving the fundamental problem, as he saw it, of the day: information overload. Sounds pretty familiar, right? Yep, even in 1945, people couldn't keep up with the amount of publications and information in their field. But here's the really cool thing, I think anyways, in this day and age of the internet, large scale search, recommenders, chatbots, all the things that we all take for granted, I think we can check off more or less at least this one aspect of Mr. Bush's vision, the extension of our memory, right? Like we have this thing now where like within seconds, we can go look up pretty much anything we've ever wanted to look up. And yet it also feels like maybe we're just falling a little bit short here, at least of this broader scope of what he was after, of how we think, right? And that includes all the modern work on large language models, et cetera. We're still just not quite there yet. And in fact, I think Bush hints in his article exactly why this is. To paraphrase and perhaps take some liberties of hindsight, I mean, we are, I don't know, what is it, 70 some years after this article, as well as tying this back to this problem I posited to you of solving a user's information need, I think much of our falling short in this space, even to this day, is primarily two main things. The transactional nature of these systems and our inability to actually synthesize the information we do retrieve at scale. In other words, we haven't actually made the problem hard enough yet. What do I mean by this? These, of course, aren't formal definitions on my part, so much as they are some of the ways I think about these problems. Transactional, for the sake of our discussion here, is pretty much every interaction you have with a machine in the moment these days, such as searching for just the right t-shirt, of course, or looking up directions to the airport, or trying to find that stack trace that shows you why your code broke when it did. It's quick, rarely goes beyond 10 blue links, and most engines on the planet treat that transaction as just another transaction in a whole universe of transactions that never, ever stop. In the middle, we have here what I'm calling iterative exploration. You all inherently know these tasks, right? They are just like transactional, but they require you, the user, to store and recall all of the prior work you did in the past around the thing that you are investigating. If you've ever planned a trip, like say coming to a conference, you know exactly what I'm talking about here, right? You know the joy that is going to the air travel site and plugging in your dates and your locations there. And then you go to the hotel site and then the conference site, and then you figure out the transportation and you put in the same dates and the same locations and you do all the same things and you pop all of that onto your mental stack. You do it for a little bit, pop it off, go do something else, come back to it, lather, rinse, repeat until you finally feel like you've got 99% of your trip figured out. Finally, I want to contrast this with what I believe no system today actually does. On the far end of this spectrum, think about what us humans are always doing. We are able to plan, collaborate, execute, update, and otherwise synthesize many different pieces of information, both factual and emotional, over long periods of time and in novel ways. And we are able to update, react, and adjust as our understanding evolves. The really awesome thing here, right? We do this all using 3 pounds of gray matter and a couple hundred calories a day. I wonder what our AWS bill will look like when we have that EC2 instance to run. Jokes aside, or maybe not jokes aside, to put it bluntly, our current stack sucks at helping us with most of these information needs. After all, almost all of the systems we use today fall into that transactional realm, and they put all of the burden on the user to figure it out. And while yes, things like session analysis, personalization, learning to rank do move us just a hair to the right, these transactions, in the sense that they learn from prior behavior, they don't really do anything to remember or bring in my context beyond, at most, the few compute cycles that we dedicate to session or prior user history. Now, you might be asking yourself, when is he going to talk about things like ChatGPT and Hugging Face and AI and all of these fancy new models we had? If you had slide 6 on your bingo card, you win. Here we are. So let's talk about it. When I think about things like ChatGPT, Sure, I get super interested in all the generative stuff we can do. There's some really amazing things happening in this space, and you're going to hear about many of them today at this show. I buy into the hype. I do. I'm what I often call a skeptical optimist. I believe in technology in the long run, even though I don't always believe in every little iteration of technology. And I, of course, worry about people doing bad things with these systems. However, what truly gets me excited when we put it in the context of this talk and the context of my own life work, what I truly get excited about is for the first time ever, we've moved that needle just a little bit closer to helping us with strategic problems, in the sense that with these bots and with these models, we can now engage with context over time. I've been in this space a long time. That is truly amazing. We can engage on information problems with context over time. Sure, right now that context is tiny and the time span is tiny. But if we're going to solve any of the problems that we as humans want to solve or actually need to solve, we are going to have help doing it. And this first step, as incredibly difficult it has been, is so important. So then the real question for all of you as builders becomes, how do we go do that? Of course, the beauty of doing a keynote is I get to stand up here and wave my hands at all the actual implementation details. You guys can go figure that out. But there are naturally a lot of things that go into this, and many of the pieces are starting to come together. And of course, I can't do justice to all of these. Probably the most important, sadly or happily for all of us, bullet on this slide is the second to last one, the economic incentives. Because let's be real, in this day and age, like most of the current set of large-scale global search providers are not actually incentivized to solve this problem. They want you to be in that like transactional state because it keeps you coming back. And so we have to think about how do we change some of those things, or at least how do we expand the way we can think about this. And so I think for us building these systems, we also have to expand our thinking to encompass all the different ways that we actually want to engage with information. So that hopefully in the long run, we are building systems that empower people to make more informed decisions. As with almost all things search, there's a lot of prior art here. Back in the day, they called this stuff all exploratory search, and it was promptly forgotten with the rise of web search. But there is actually a lot of people who did a lot of good work on this. And what we really need to do is bring it forward, just like we brought forward the old work on neural nets once we actually had the compute power to do it. I want to leave you with one final paraphrase from Vannevar Bush's article, where he just simply asks at the end of the article how we might all do this in the name of really helping us as a species grow in our wisdom and our ability to take care of each other. I want to thank you for your time and for indulging me on how to make your job harder. Enjoy the show. Thank you.
Thanks, Grant. When you think about where search is headed, artificial intelligence and machine learning are central to the story. The rise of large language models and generative AI has made AI technology widely available for integration into applications and software. These models and other AI technologies are powering new chat-based search experiences, better summarization of results, improved relevancy, and many more new types of capabilities. The OpenSearch community has been active on this area for a couple of years now. Since OpenSearch launched, it's had built-in support for KNN with scale up to 16,000 dimensional vectors, and supports a number of algorithms from a range of libraries like NMSLib, FACE, and Lucene. Building on these capabilities, last year we launched the neural search feature to simplify the process of generating embeddings, ingesting them, and searching them, all with natural language models. Behind these AI technologies are vector databases which store, search, and retrieve vector embeddings. OpenSearch has grown to be a popular vector database solution because of its built-in ability to store and search embeddings. In fact, we are seeing more and more developers building their generative AI applications with OpenSearch as their vector database of choice. As a project, we are at just the beginning of our story with generative AI, and I'm excited to see multiple people and organizations contributing to OpenSearch to help move this community forward. In fact, the team at Aaron has been working hard to enhance OpenSearch to better support AI applications. That is why I'm thrilled to introduce you to Mehul Shah, the CEO of Aaron. Some of you may not know this, but Mehul has a long history with OpenSearch. He was the former general manager of OpenSearch at Amazon, and his support was critical in getting the project off the ground. Mehul is here to share more about how OpenSearch fits in with generative AI, how his team is enhancing OpenSearch to better support this emerging area. So everyone, please join me in giving a warm welcome to Mehul.
Wow, it's good to see everybody here. A lot of familiar faces in the audience, a lot of new faces in the audience. And, thank you for inviting me here on this stage. It feels like home. And what better place than home to announce that we at Aaron today, right now, are coming out of stealth. Really exciting times. But before I get started, I want to tell you a little bit about myself and my history with this community, the OpenSearch community. You see, I was the general manager of the Amazon Elasticsearch service. And in 2021, January, we kicked off OpenSearch at Amazon. My colleagues and I convinced Andy Jassy and the Amazon leadership to do something that they weren't used to doing, which is to steward an open source project and community. And that was the right choice for them. That was what their customers wanted. It was the right path. And I was hopeful that it was also the right path for the users and this community. And while I was there, we mostly laid the foundations for OpenSearch. We didn't have much room to do anything else. We were thinking about operational stability, release cadence, project roadmap, and small features. And then about a year later, things were going well. We saw about 1 million downloads a week, and I could see that number ticking up and to the right. And I could tell that OpenSearch was going to be big. How big? I wouldn't have imagined, but I felt it would be at least bigger than what Amazon is today. And while we were there laying the foundation, I also saw another trend in the community, in the AI community in particular. And they were building machines which were amazing at mimicking human behavior. I'm sure you guys have all tried this. And if you haven't, what rock have you been hiding under? Okay. These generative AI models, large language models in particular, are amazing. If you've tried ChatGPT, if you haven't, go try it. You can basically give it natural language commands and it'll tell you a joke, write a limerick for you, respond to an email, summarize a book. And if you take a look at their growth, about 7 years ago till now, these things have been growing in terms of the number of parameters almost 10x per year. That's a logarithmic graph. So it's like a Richter scale. Can you imagine how fast these things have been changing? And more importantly, look at the behavior that they've been showing, the emergent behavior. They can do things that they weren't originally trained for. And most importantly, the capabilities that we're interested in are for their capabilities for processing unstructured data. And it's remarkable. They can do things like information extraction, question answering, summarization, content generation, and more. And this has sparked the imagination of not just us, but people across the industry, some of our customers. For example, in an investment firm, analysts need to filter through and analyze thousands of research reports, both internal and external, to form an investment thesis. Or a manufacturing firm, for example, has thousands and thousands of manuals for the parts that they've built over the years. And they want to enable their customers and their users to find on their own which parts are useful for their use cases and which ones are compatible. And what we're seeing here is a brand new powerful paradigm for these use cases called conversational search, or chat with your enterprise data. This is what I call it. Okay. Companies want to build applications where users can retrieve relevant data, summarize it, synthesize answers from it, and then in that same context, ask follow-up questions. And they want to do this not over their log data, but also their PDFs and their presentations and images and so on. And today, that data is just largely sitting idle. It's dark, it's untapped, and they want to use generative AI to power these conversations and get value from it. So how are they doing this? Well, one option is to take these generative AI models and put them at the center of your universe and just ask it questions, okay? Now, these things they're trained only on public data. So if you ask it questions, it's not going to work out of the box. It doesn't know anything about your data. And so it will confidently give you a lie. It's also known as a hallucination. Right? And training is prohibitive. If you try to train these models, you need special expertise, lots of data, and lots of costly hardware. So instead, what we're seeing is a different trend where people are trying to take all their data, chop it up into smaller pieces, and bring it on demand when the question is asked to the AI model. I call it bringing data to AI. Okay? And what it does is that these AI models, when they're seeing the relevant data in front of them, they do a better job of giving you an accurate answer. It's an architectural called Retrieval Augmented Generation, RAG for short. And so we see tons of customers building complex search stacks on their own with Gen AI toolkits and vector databases that are all in their infancy. And they're hard to scale and they're hard to maintain in the long run. And also only solves half the problem. The other half of the problem is, how do you get good data into these systems that you can then present to the AI so you can get good answers? And today, you're left on your own to solve this problem. And so this is where we kind of scratched our heads and said, well, what about this thing that we have here called OpenSearch? Why can't we start there, right? It's already got a ton of the components that you need, a vector database, the term index, but more importantly, it's a full-featured search engine, open source, tried and true. It's got thousands of customers running in production. Thousands of developers use it every day. And it's got enterprise-grade security, monitoring, scalability, manageability, so you can get to production faster. Why not start here? Okay. But there are things that are missing. And so we asked for ourselves, well, how do we get the best of both worlds? Here are two different paradigms for handling, getting answers from your unstructured data. How do you put these things together, make them work well together? And so today, I'm proud to announce that we've closed that gap with Aaron. We're releasing a conversational search stack that makes it easy for developers to build and scale their conversational applications on their enterprise data. We're builders. We're a database and big data people from a bunch of cloud companies like AWS, Google Cloud. And our roots and our mission is to answer questions from all of your data. We're doing this by helping to bring generative AI to OpenSearch. And another goal of ours is to help expand and grow the OpenSearch community. We know AWS can't do it alone. And so now I'm going to go and borrow an idea from 50 years ago. So Grant, you beat me. You went all the way back to 1945, but 50 years is still pretty powerful. And there's a guy by the name of Ted Codd. He was the father of relational database systems. And he had a very simple and powerful idea. Okay. And it was, let users specify in a concise language what they want, and let the system figure out how to get the answers from the data. And his insight was very powerful, which was, you can actually take these very simple operators, compose them in a pipeline to answer any SQL query. He also had another project, lesser known, and it was around natural language questions over unstructured data. but the technology wasn't ready. It didn't go anywhere at that time. Now with LLMs, we believe the big challenge is figuring out how to build these pipelines to accurately answer these questions. And we're data people, so we don't see AI at the center of our world. We actually see data pipelines, and data flows. And our approach is to bring AI to the data flows. And one thing that's obviously missing in all of the data flows that we see today is this data preparation step. We think that's the missing link for bringing good data to these AI systems to get good answers. We also believe that developers should be able to pick and compose the best AI at each stage to solve the problem at hand. And then combining search stacks with generative AI in this way is going to give us the best of both worlds. And so this is where Aaron comes in. It's a one-stop shop for building your conversational apps. At its core is OpenSearch, the tried and true open source enterprise search engine that we're all familiar with. You can get to production faster because it's all ready with all the features that you need. What we've done in 2.10 is add conversational capabilities, a conversational memory implementation that allows you to keep track of the interactions that you've had in your conversation, as well as a RAG search processor that coordinates the interactions with LLMs to synthesize answers. But that's only solving half the problem. The other half the problem, I'm proud to announce a brand new open source project called Sycamore. It's a scalable semantic data preparation system, purpose-built for search. It's Apache v2 licensed. Sycamore's programming model is very much like Apache Spark, but for processing unstructured data using LLMs to get high-quality answers from LLMs. Here's what Sycamore looks like. On the left-hand side, we have a research article. And within a few lines of code, you can segment this article into chunks. You can identify things like titles and authors, and can turn all these things into JSON documents that you can embed in OpenSearch's vector database for search and retrieval. Now, open source isn't just about projects and code, it's about community. We're just getting started off the ground. Go and check out these links to go and look at our projects, give us some feedback, and come join us so we can all benefit. Help us contribute so we can all benefit. And stick around for the next session, and I'll double click into Aaron. Thank you very much.
Thanks, Mehul. Before we kick off the rest of our second ever OpenSearchCon, I'd like to briefly wrap up with a few closing remarks. First, I'd like to thank all of our partners and exhibitors today who are helping make this community and this conference possible. Everyone, please, if you haven't, go check out the exhibitor space. I'd also like to thank you all once again for being here and being part of our community. Though we have made a lot of progress this past year and seen incredible growth, the topics our guest and myself have touched on just scratch the surface of what I believe we can achieve together. We have a ton of awesome speakers lined up today to dive much deeper into the world of OpenSearch. So let's have some fun, let's get inspired, and let's learn as much as we possibly can from each other, because someone in this room may just have the next great idea for OpenSearch. Thank you.